Very good morning, students. I'm Aisha Nasreen, working as an assistant professor in EC department, RMD Engineering College, Kavaraipete. Today's topic is pulse and data communication. This is the second unit of analog and digital communication for information technology students. In this unit, we are going to see about pulse code modulation. First of all, what is mean by pulse modulation? Here, in the previous unit, analog modulation, both the message signal and the carrier signal are taken as continuous signals. But in the pulse modulation techniques, the carrier signal is taken as a pulse of signals. Okay, so the pulse is taken in pulse code modulation technique is the today's topic. In today's topic, we are going to see about the block diagram of pulse code modulation. So the pulse code modulation has various types such as pulse amplitude modulation, pulse width modulation, pulse position modulation. Okay, so in today's topic, pulse code modulation means the modulated signal is converted into a code during the transmission in the channel. Okay, this is nothing but a simple and analog to digital conversion and digital to analog conversion again. So the pulse code modulation, the main thing going to happen is analog to digital and digital to analog conversion. So first we are taken as an analog signal. The analog signal is given to a band pass filter. The band pass filter will send only a band of frequency, and from the band of frequency the sample and hold circuit will take the samples. Okay, then we are going given the data to the quantizer and then to the encoder technique. So in this today's unit we are going to see about each and every block separately. So first, in pulse code modulation, the message signal is represented by a sequences of coded pulses. This message signal is achieved by representing a signal in a discrete form, both the time and in amplitude. So first of all, the analog signal is converted into a discrete form. This PCM is widely used in public switched network, and it is very helpful in combining the voice and data into a single high speed signal. So the operation of band pass filter is the band pass filter limits the frequency of analog signal, and it considers and it allows only the frequency range between 300 Hz to 3000 Hz. And then sample and hold circuit. From the analog message signal, we are taking as samples with a train of rectangular pulses, and it should satisfy the Nyquist criteria. Those sampling rate is greater than equal to twice the highest frequency of message wave. So a continuous signal after getting into the sampling operation is converted into a limited number of discrete values per second. And then we are going for encoder. So the encoder translates the discrete set of samples into an appropriate form. Okay, it will encode the signal. Then we are going for regenerative repeater circuit. So this regenerative repeater circuit is used to strengthen the signal. The output of the channel also one regenerative repeater circuit. Okay, so this regenerator repeater circuit helps to increases the amplification. It does not it gives a strength to the signal during the channel when the signal is passed through the channel. So the repeater circuit is widely used not only in pulse code modulation in applications such as microwave signal transmissions, in mobile communication and all. We are using more number of repeaters so that it will strengthen the signal while it reaches the receiver section. Okay, the regeneration is the ability to control the effect of distortion by a chain of repeaters at a regular intervals. And then what are the unique operations of these regenerative circuits? It's equalization. So it shapes the received pulses to compensate for amplitude and phase distortions. The distortions during the transmission is overcome by the equalization process, and then it maintains the signal to noise ratio. So the signal to noise ratio should be high in order to retrieve the signal back in the receiver section. So, and the decision making will helps to maintain the amplitude of a pulses without exceeding a voltage level. And then decoder circuit. In the decoder circuit, the obtained receiver signal is decoded. This performs the operation with reverse operation of encoder and into a quantized PAM signal. So then the reconstruction signal will reconstruct the actual frequency of signal. So in the sampling process itself, we are maintaining a formula that is Fs is greater than or equal to 2Fm. That is, the sampling frequency should be greater than the twice of the maximum frequency of the signal. Okay, so while you are satisfying the sampling frequency, then the reconstruction is very easy. So the Nyquist formula is used in the sampling section. So reconstructing the signal is also very easier here. So this is the general block diagram representation of the pulse code modulation. And this modulation technique is generally, we call it as a pulse analog to digital and digital to analog conversion process. Before doing this process, first the pulse amplitude modulation takes place up to sample and hold technique. After that, the quantization and encoder process or the unique process of this pulse code modulation technique. Thank you, students.